Hello, this is Susie Newhan, and this is the one about differentiating with fractional, negative and symbolic powers. And what do I mean by symbolic powers? Well, that sort of thing. Okay, just a quick disclaimer that you're going to see some pretty nonsensical economic functions in this video, but it's just to give you some practice. So, before we start, let's remind ourselves how we multiply fractions, because some of my students haven't done this for a while. So, if we're multiplying a fraction by a fraction, we multiply the tops, we multiply the bottoms, and we get 7/6. But if we're multiplying a whole number by a fraction, we only multiply the tops. So, for instance, 22 times a half is 22 times 1 over 2. You get the idea. Now, some people might prefer to make this sort of problem into that sort of problem, and you can do that. You can make 22 into a fraction by putting it over 1. Every number is a fraction over 1, and then multiply top and bottom, and we will get the same answer. And so some people do it that way. But we only need to multiply the top row. So let's get some practice with differentiating with fractional powers. Okay, it's just like we did before. We're multiplying powers by the coefficient. So we got dy by dx equals a half times 8. Some of these powers don't look like powers. That's Microsoft Word for you. A half times 8 is 4. X, right, now, as always, I have to subtract 1 from the power. And a half minus 1 takes us into negative territory. Minus a half. If we take 1 from a half, we get minus a half. What about this one? We get dy by dx. 2/3 times a third. We can, if we want, write this sort of longhand. So I'm multiplying the power by the coefficient. Doesn't matter which order I put it in. And I'm going to subtract 1 from 2/3. So if I've got 2/3, subtract 1, I go 1/3 into debt. And then I can clean this up. I can think of this as 3 times 2 is 6 over 3, which is 2, or we could think of these two as cancelling out and leaving a 2 that away. Right, this one, we got dy by dx equals 1/3 times 9 is 3. X to the minus 2/3. I subtract 1 from a third. Plus, here, I've got to multiply a half by another fraction. This is going to be x to the minus a half. And tidy that up, 3x minus 2/3. Plus, multiply the tops, multiply the bottoms, x to the minus a half. Okay, now differentiating with a negative power. So we're going to find dq by dk here. We're going to multiply the power by the coefficient, minus 6, k, drop the power by 1, minus 2. How does that look? Hopefully that looks terrible, because that's wrong. And not only is that wrong, that's very serious. Because why is that wrong? It's because minus 3 minus 1 is minus 4. So please don't do that. It's one of the common mistakes of differentiation. Okay, minus 3 minus 1 is minus 4. It's going more negative than it was. Okay, here's some more practice with negative powers. We're going to try not to kill any kittens. So we've got dp by dq equals minus 50. Q minus 1 minus another 1 is minus 2. We've got dq by dl equals, I'm now multiplying a negative number by negative number, so it becomes positive, and that gets 1 more negative. And this one, dq by dk, negative times a negative is going to be positive. Alpha is just a constant, minus 13. So one more, but this time we've got a little bit of negatives and we've got some fractional coefficients, but that's all right. dp by dq equals, so I'm now going to multiply minus 4 by fraction, so I'm only going to multiply the top of that fraction, so it's going to be minus 8 over 3 cube, subtract another one from that, minus 5. So I've got total revenue here. So I'm going to multiply negative by negative, it's going to become positive, and I'm going to multiply the top of that fraction by 3, so that's going to be 6 over 3 q to the minus 4, which is going to be 2q to the minus 4. So one more with negative powers. They don't look like negative powers, but they are going to become negative powers because we can't differentiate these when they're on the bottom. So we always have to bring them to the top. And hopefully you'll remember from the work we did on powers that when we bring a term to the top, we are changing its power to negative. So for instance, before we differentiate this, we're going to bring the x to the top, and hopefully you will remember that it will become x to the power of minus 1. Or whatever the power is. So I bring it to the top first, and then I can differentiate it, because then it follows the same pattern as before. So minus 1 times 4 is minus 4, x to the minus 2, no killing kittens there. dp, oh no, first I have to rearrange it. So p also equals 9x to the minus 3, and then I can differentiate it. Minus 3 times 9 is minus 27, x to the minus 4. And then here I've got 3x to the minus 3 plus, now here I've got a 3. I'm not going to bring the 3 up because the 3 isn't included in that power. It's just out there on its own. So it stays there. I bring the x squared up and make it x to the minus 2. The 3 stays there, and it was only 1, so there's a sort of 1 in there next to the x. And now I can differentiate. So minus 9x to the minus 4. This is going to come negative now because it's going to be minus. So minus 2x to the minus 3 over 3. So depending on your context, you might want to put these back below again. So this might also be written as x over positive 4, because the x minus 4 shows that the x term really belongs on the bottom. All right, how about something with a mix of fractional and negative? So here we need a bit of rewriting here. You hopefully will remember that q, square root of q is really q to the half. So I'm going to write this as 4 over q to the half, which means I can bring the q to the top and make it minus a half, and then I can differentiate. Minus a half times 4 is minus 2. Q minus 3 over 2. If I've got a power of minus a half, I subtract 1 to it. I go further negative, so it's like being negative by 1.5, which we would normally write as 3 over 2. We don't tend to use mixed fractions in powers. All right, this one will be p equals 6 to the q minus 2 over 3, so dp by dq will equals minus, because that will be negative, 6, let's write it longhand, 2 over 3 q. Now I've got minus 2/3, I'm going to go another 3/3 negative, so it's going to end up as minus 5 over thirds. Now if you have trouble with these fractions, and some people do, your calculator is really good at them. So if you put in minus 2/3 minus 1, you will get minus 3/3, minus 5/3. So tidy this up a bit. I'm going to multiply only the top of the fraction, so I've got minus 12 over 3. Q minus 5 over third, and I've run out of space, so I'm just going to make that minus 4. 12 over 3 is minus 4. And then just one more slide of symbolic powers, which in some ways are easier. Okay, so here we've got parameters. that we don't know the value of. We treat them as constants. They're not variables, so we don't differentiate with respect to them. They're just constants we don't know the value of, and we might want to change selectively, but the variables are written in capital letters, and those are the ones that we'll differentiate with respect to. So here we're going to differentiate Q with respect to L, and as always we're going to multiply by the power, 8 times alpha, and now the power will become just alpha minus 1. Makes sense, doesn't it? If we have a mix of numbers and letters, we normally put the numbers first, but it doesn't matter. So here we've got dq by dk is going to be alpha beta k alpha minus 1. I switched those two around because I happen to know that alpha comes alphabetically before beta in the Greek alphabet, but it doesn't matter. Here we're going to have dq equals dl. I'm now going to have minus, and I'm going to have alpha times alpha, and I would probably simplify that to alpha squared. So I've got minus alpha minus 1. So whatever the power is before, you just subtract 1 from it. So here we have dq over dl. It's going to be minus, let's write it longhand, 7 times alpha over 2 times another alpha, because there was already an alpha there, L to the alpha over 2 minus 1. You see what I mean? These are rather nonsensical functions. So this is going to be equal to minus, I've got alpha squared, I've got 7, I'm going to put them all over the 2. They don't all have to go over the 2, but because they're multiplied, they can all go over the 2. So that's that. And then finally, dq by dk, negative times a negative, so it's going to become positive. I'm going to have a beta over 5 times k to the minus beta over 5 minus 1. Okay, I hope that was helpful.